So what we've now done is we've covered all the techniques, all the skills, and all the material you will need to look at in order to be able to work through differentiation at higher level, regardless of the scenario. What I'm going to do here is I'm going to do two videos for you. The first one, which is this one, is going to focus on some of the more straightforward techniques and straightforward types of question that you may get in the papers. The second video is going to look at the more complex ones, including applications of them. In this video, what I'm going to focus on is I'm going to focus on more of the C standard questions, so some of the techniques and the skills that you would need to work with rather than how we apply them. So I'm going to focus on that. I've got 3 questions for you to do. I want you to pause the video, have a look at these 3 questions and see how you get on. Now, all 3 are taken from past papers, so they're all examples of exam material. There you go, there's your 3 different questions. So one is just determine dy by dx. The second is looking at the graph and its stationary points, determining which statement is true and how it applies to the scenario. And the third one is looking for maximum and minimum values on closed intervals. So, pause the video and have a crack. So the first one was if y equals 3x to the negative 2 plus 2x to the 3 over 2 where x is bigger than 0, determine dy by dx. So this sort of question will be thrown in there to make sure you can differentiate, to make sure you can calculate the derivative of a function. Now it's written in the form that we want. So it's written in the form ax to the n for every single term, so we can straight up differentiate it from that. So what we're able to say is dy by dx equals, and do each term on its own. So take the coefficient of 3 and then we multiply it by the derivative. So bring the power down, negative 2x, and then reduce the power by 1 to the negative 3. Then it's plus, and the second one's the same. So 2 times, bring the power down, we get 3 over 2x, and then reduce the power by 1 to the half. And then it's just a case of simplifying each part here. So 3 times negative 2, that gives me negative 6x to the negative 3. I've then got plus 2 times 3 over 2 plus 3x to the half. So that's it. I've got my dy by dx. I've determined it. Sometimes it might ask you to put it in its simplest form or with positive indices. And in that case, if it did that, we'd have it as negative 6 over x cubed plus 3 times the square root of x. We could write it in that form. But if the question doesn't specify it, this sort of answer here would be perfectly acceptable. Now this question here is all about taking the graph and using the information we know and how the derivative translates across to the graph of a function in order to determine some key qualities about it. So it's got stationary points at 0, p and q, r, and here's 2 statements about the graph. So the first one is f of x is less than 0 for x somewhere between s and t, and the second one is the derivative is negative for x less than q. So I want to know which of the following of these 4 is true. None of them are right. Only statement 1, only statement 2, or both are correct. So what you do is you look at each statement on its own. So for the first one, f of x less than 0 for x between s and t. So what it's asking me, if I take x between any value here, in this section here, my function is negative. Well, you can just look at the graph and know that. Everything here is less than y equal to 0. Everything here gives you a negative value regardless of which value along here you substitute in. So the first statement, number 1, is true. So I could initially say, right, it's definitely not going to be A. And it's definitely not going to be C. So either only statement 1 is going to be true or both statements are going to be true. The second one is f dashed of x is less than 0 for x less than q. Now remember, if the derivative is less than 0 for x less than q, that tells me the gradient is going to be negative, so my graph is going to slope this way. And it looks like it does. It's always coming down. However, we know that P is a stationary point. And we know then that a stationary point, the derivative f dashed of x equals 0 at that point. And look at the way it's phrased the question. F dashed of x is strictly less than 0. It's not included it, so it's not said less than or equal to. It's strictly less than 0. But at this point here, the derivative is 0. So if I take any value of x along this way, except x equals 0, it would be true. But it's saying any value less than q, so the second statement 2 is not true. So what I know then is that B is correct. Only statement 1 is correct because that's the only one that satisfies the conditions. This kind of question is all about getting you to interpret it and think about what you know about the functions, what you know about the derivatives and the characteristics of it. The last question was looking at maximum minimum values in closed intervals. So function f of x is defined on this domain, 0 less than or equal to x less than or equal to 3. And this is the function here, f of x equals x cubed minus 2x squared minus 4x plus 6. I want the maximum minimum values. Now remember, if we had a closed interval here from a to b, our maximum minimum values could only occur at a, b, or any stationary point within this bit here. Has to be in here, and it could be any stationary point, because that would be where the curve is either a maximum or a minimum going like that. So we have to calculate all of those. To get the stationary points, we take the derivative. So we start by calculating f dashed of x. So calculating the derivative of that gives me 3x squared minus 4x minus 4. And I know to get the stationary points, that equals 0. So if I've got 3x squared minus 4x minus 4, to solve it, I factorise. Factorise that into two brackets, you get 3x plus 2 and x minus 2 equals 0. What that then gives me is two solutions, x equals negative 2/3 or x equals 2. So there's my stationary points for the curve. However, look at our domain. X is between 0 and 3. Negative 2/3 is out with that, so this one here I can actually ignore. So what I then know is my maximum is going to occur at either x equal to 0, x equal to 3, my two limits of my domain, or x equal to 2. So I've got these three here now, substitute them into this, and I'll be able to tell you which is the maximum minimum. So f is 0, well, that's equal to 0 cubed, take away 2 times 0 squared, take away 4 times 0 plus 6, which I hope you could realise was 6. So x equal to 0, the lower part of my domain, the value is 6. If I then look at f of 3, well, that gives me 3 cubed, take away 2 times 3 squared, take away 4 times 3 plus 6. 3 cubed, that's 27, so I've got 27, take away 2 times 3 squared, well 3 squared is 9, 2 times that is 18, take away 4 times 3, which is minus 12, then plus 6. 27 take away 18 is 9, take away 12 is negative 3, plus 6 gives me a value of 3. So x equals 3, my value is 3. This is definitely not going to be the maximum, but it could be the minimum. We then have to look at f of 2, where x is equal to 2 and see what value we get there. So I get 2 cubed, take away 2 times 2 squared, take away 4 times 2, plus 6. 2 cubed is 8, so it's going to be 8, take away 8, minus another 8, plus 6. 8 minus 8 is 0, take away 8 is negative 8, plus 6 is negative 2. So what I can read from there is that my maximum occurs at x equals 0, my minimum occurs at x equals 2. We then have to interpret it and communicate the answer. So what we then say is, therefore, x equals 0 gives me the maximum of 6, and x equals 2 gives me a minimum of negative 2. We have to make sure we communicate that final answer. We have to tell them what we've got, what the values are, why we've chosen it, and where they come out. These are just 3 standard questions that you can get for differentiation that look at the skills that you'll need to build on to then be able to answer more elaborate, tricky questions.